Writing and graphing linear equations. This first example is to write the slope of a line containing each pair of points. As a reminder, slope is the change in y over change in x. We can also think of that as y sub 2 minus y sub 1, that quantity divided by x sub 2 minus x sub 1. I think it's a really good idea at this point to label those points so that we don't lose track of them. So I like to put an x sub 1, y sub 1 underneath the first point, and x sub 2, y sub 2 underneath the second coordinate pair. If we do this, we can easily substitute in place of those variables, and in this case we would get 7 minus 4 equals 5 minus 3. We have to be very careful to keep track of the positive and negative integers. Here we see that the slope would be 3/2. This is the example of how you find the slope of a line. With this next example, we're given just 2 points. And here once again we want to find the slope of the line. And these aren't quite as easy to work with, so I just wanted to show you one second example. If we look at this formula that we used in the last example in another way, it might be easier for you to organize your work. So here again I label the coordinate pairs as x sub 1 and y sub 1, x sub 2 and y sub 2. So when we substitute, notice that the y's are on one side, and this might seem a little bit easier to work with because it's not in the form of a fraction. So when we substitute, we have 20 minus a negative 13. Notice how I use those parentheses, and then m, which of course stands for slope, that negative 61 minus that positive 10. Simplify in any way that you see fit, as long as we follow order of operations, and we're left with 20 plus 13 is 33, with m groups of negative 71. Undo this or solve like any other equation, and we have a slope of 33 negative 71st. So in the form of y equals mx plus b, if we wanted to, we could substitute that slope 33 negative 71st in place of m, and then use either one of the points to solve for b. And I won't keep going with this, but I just want you to see that it's a simple substitution just like we've always done, and then we would continue and solve that particular exercise. This next example asks us to identify the y-intercept in each equation. Right now the equation is written in standard form, so it's a good idea to solve the equation first for y so that it would be in slope-intercept form. We do that by undoing it or using inverse operations and isolating the variable y on the left side of the equation, so that we're left with y equals negative 3 plus 2/4 x. But it's not quite in slope-intercept form, which would be y equals mx plus b. So first I'm going to simplify that fraction 2/4 to 1/2 x, and making sure that I keep track of that negative symbol, I have a negative 3. In slope-intercept form, you'd have your output first on the left side, which is y, our slope identified as a fraction 1/2, the x variable, which is the input, and then that y-intercept, which is the negative 3, or that constant value following the variable x. When we write a y-intercept, we typically use a coordinate pair. So that coordinate pair in this case would be 0, comma negative 3, which states when x is 0, our output would be negative 3. And this is the y-intercept. This example gives us a slope of 2/3, and it tells us that the line passes through the coordinate pair negative 3, comma negative 2. So if I think slope-intercept form y equals mx plus b, I can substitute in place of m and get y equals 2/3 x plus b. Well, in this case, I know that I have a y value of negative 2 and an x value of negative 3. That's given information. And as a general rule, when solving for variables, if I only need to find one variable, I can always solve for that. So negative 2 equals negative 2 plus b. I add 2 to both sides to isolate the variable b, and I'm left with b equals 0. So in y equals mx plus b now, knowing that my slope is 2/3 and my y-intercept is 0, I have the equation of my line, y equals 2/3 x. I don't have to write the plus 0 because the identity property of addition says that adding 0 to anything would give me the same value. This example asks us to find an equation of the line through the given point and parallel to the given line. So we need to think a little bit about what slope tells us. The first thing I did here was to isolate the variable y on one side, or put that equation, which was in standard form, into slope-intercept form. After doing that, I need to think about my slope. The slope of a parallel line would be the same. So in my new equation, I should write y equals negative 3/2 x plus b. Then it also told me that I know my point is 2, comma, negative 1. In place of y, I substituted negative 1. In place of x, I substituted 2. And now I can solve for b. After I've isolated my variable b on the right side, I know that its value is 2. I can now rewrite my equation in slope-intercept form as y equals negative 3/2 x plus 2, which is the equation of the line given the point 2, comma, negative 1 that was parallel to that original rule.